I want to take a look at one more application problem. Now the last one was actually very nice because they gave us the formula for the thing we wanted to find the maximum for. This problem, there's a similar example in your text and there's a similar problem in the homework. This one we do have to do a little bit more work because we're going to have to come up with the formula before we can find the maximum. Okay, so here's what we have. We have 100 feet of fencing and we're going to build 3 sides of a rectangular pig pen. Now, you might think that sounds very foolish because if I build 3 sides of a rectangular pig pen, then I could put my pig right here. That is my pig. And the pig could run away. Okay, but the picture illustrates why this is not a dumb idea. The 4th side is actually going to be against a barn. So there's an existing structure, so we only have to build the other 3 sides, and our pigs will be safe inside the pig pen. I know you were worried. All right, now we all know that pigs like nothing more than to romp and frolic. So to keep our pigs happy, we want them to have as much area as possible in which to romp and frolic in their rectangular enclosure. Okay. So what we want to do is see what is that maximum area. And that's going to depend on how I divvy up my fencing between these 3 sides. Now obviously these 2 sides are going to have to be the same length because otherwise I won't have a rectangle, but I can decide how long to make those sides. Now I'm trying to maximize area, and I know that area is just length times width, so it would just be x times y. Now the problem is right now, that's a function of 2 variables. Multivariable calculus is years away. You've got this class, first semester, oh, it's only a year and a half away. Okay, you've got this class, you've got first semester calculus, you've got second semester calculus, then you can take 3C and learn how to do this as a problem with 2 variables. But we only know how to deal with functions of 1 variable. So what I need to do is use this condition, which we sort of call our constraint. That tells us we don't just have unlimited amounts of fencing. If we did, this would be a silly question, just build a bigger pig pen, okay? But I know I only have 100 feet of fencing to use between these 3 sides. So that tells me that 2x plus y is going to have to equal 100. 2x plus y, that would be the sum of all of the fencing that I use, okay? And obviously if I want to maximize the area, I'm going to use all of the fencing, okay? All right, that gives me a relationship between these. So I could solve for y, and I could say it's 100 minus 2x. Now, if you preferred, we could have solved for x. I was just feeling lazy. If I solved for x, I'd have to subtract over y and divide by 2. I can solve for y by just subtracting over the x's. Now, if I plug that in, I get that area is x times 100 minus 2x. So I can now think of that as a of x. Area is a function of my 1 variable x, and it's given by this formula. I think I'm going to go ahead and multiply that out. That's 100x minus 2x squared. Oh my goodness, that's a quadratic. Oh, this is so exciting. I'm going to just write that with the squared term first because that way it looks a little bit more familiar. Okay, excellent. Okay. Now, the natural domain of this function would be all real numbers. I can plug in anything I want. That is not the actual domain that we have for this particular problem because x is going to represent a side length. So the physical constraints of this problem tell me that x is going to actually have to be between 0 and 50. Now 0, because I can't have a negative length. I could make x 0. That would be a really stupid choice. That would mean I would build one wall flush up against the barn and there would be no room for the pigs. Lousy choice, but could be done by very stupid farmers. Okay, 50 would be if I put these sides super close together, so I made y 0, but I still have to build 2 x's. So if I used all 100 feet up with both of those sides, each of them would be length 50. Okay, so that's the part of this that I care about. Okay, and this is going to be a parabola that opens down. Before I erase this, we were asked to find the maximum area. That's our question. So I like to have a picture that tells me what we're going to have is x here, which is just a side length, and a here, which is the area. Okay. And we're expecting to have a parabola that's going to be opening down. Okay. I can see if x is 0, I'm getting 0. And so I'm looking at something that looks something like this. I could actually, if I wanted to, see where we are at 50, and it turns out at 50 we're going to be back at 0. I'm not concerned that you have a super accurate picture. What I want is a parabola that's opening down. That tells me I've got a max. And what we have for our vertex is an x value and then an area. Now the question asked, what's the maximum area? So I only care about that, what's in the position of what's usually the y value. But to find it, I'm going to have to find the x value first. So notice that with this particular equation, my a is -2, my b would be 100, and I'm not going to need c, but if I did, kind of a good habit to just write them all down, c would be 0 because there's no constant term. So my x value of the vertex is at the opposite of b over 2a. That's going to be -100 over -4. That's at +25. Very good to see that that is in the domain for this problem. Obviously, it's in the mathematical domain for this function, but this is within the constraints of the real world settings. I can actually build something using 25 feet of fencing for each of the x sides. Okay. So now I want to find the area at 25. So the area at 25 is -2 times 25 squared plus 100 times 25. Just plugging in 25 for those x's. Let's see, 25 squared is 625. So -2 times 625 plus 2500. That's going to be -1250 plus 2500. That's going to be 1250. So the maximum area is 1250. And we should be used to, in application problems, including the units in our answers. I will often require that, and I'll usually remind you in the directions and say include the units. So what are the units? Well, they're not feet, because that would be a measure of length. If I'm measuring length in feet, and it was in feet, we had 100 feet of fencing to begin with, then area would be in square feet. Okay. So knowing the units for length tells me the units for area, but they're not exactly the same.